Dear students, let us continue from where we left in the last class. Today, in this video, we shall discuss derivatives by substitution. Derivatives by substitution. Okay. Say, in an expression, whenever we see root of a square minus x square, the natural substitution is either x equal to a sin theta or x is equal to a cos theta, which we have seen in our earlier chapter also. During the inverse trigonometric function also we have seen, whenever we want to simplify an expression and if that contains root a square minus x square, then put x equal to a sin theta or put x equal to a cos theta. And suppose if we have root of a square plus x square or root of x square plus x square, then what is our substitution? X is equal to a tan theta or x equal to a cot theta. Why do we make such a substitution? Because the whole purpose of making this substitution is to make that function simple, so that differentiating it would be easier. Okay. So if I substitute x as a tan theta, then I am getting a square plus a square tan square theta. Taking a square as common will give you a square into 1 plus tan square theta. 1 plus tan square theta is secant square theta. Root of a square secant square theta can be written as a secant theta. So then onwards differentiating will be easy or simplifying will be easy. That is the reason why we make this substitution. And suppose if we have a root of x square minus a square, then you know that the substitution should be x is equal to a secant theta or x is equal to a cosecant theta. Okay, then one more expression where usually we come across is root of a plus x or root of a minus x. When you have root a plus x or root a minus x, go for the substitution would be x equal to a cos theta. Either a cos theta or a cos 2 theta, anything is okay. Why do we take x equal to a cos theta? If I take a cos theta, then you have a plus a cos theta. Taking a common will give you a into 1 plus cos theta. A into 1 plus cos theta, that 1 plus cos theta is equal to 2 cos square theta. So simplification will be easier. Similarly, here you will get a minus a cos theta, which is a into 1 minus cos theta. 1 minus cos theta is 2 sin square theta by 2. That will give you root of 2a sin square theta by 2, which we can write as root of 2a into sin theta by 2. Okay. So that simplification will be easier. Remember this. So when we come across these expressions, these are the substitutions that we make. Okay. Now let us solve few problems on this. If y equal to tan inverse of root of 1 minus cos x divided by 1 plus cos x. Y is equal to tan inverse root of 1 minus cos x by 1 plus cos x. Then prove that y dash is equal to 1 by 2. Prove that y dash is equal to 1 by 2. Okay. So we have y is equal to tan inverse of root of 1 minus cos x divided by 1 plus cos x. Okay. Now 1 minus cos x, we can write 1 minus cos x as 2 sin square x by 2. As you know, 1 minus cos theta is equal to 2 sin square theta by 2, which is a very well known formula that we have learned in our first QC. And similarly, 1 plus cos x, that is equal to 2 cos square x by 2. 2 gets cancelled. Okay, then you have sin square x by 2 divided by cos square x by 2, which is tan square x by 2. Root of tan square x by 2. square x by 2, I can write that as tan x by 2. Tan inverse of tan x by 2 is equal to x by 2. So y is equal to x by 2. Now you differentiate it. Y dash is equal to 1 by 2. Okay. Now let's go to the next question. If y is equal to tan inverse of sin x by 1 plus cos x, tan inverse of sin x by 1 plus cos x, then prove that y dash is equal to 1 by 2. Then prove that y dash equal to 1 by 2. Okay. So let me take this. Y is equal to tan inverse of sin x divided by 1 plus cos x. Okay. That's equal to tan inverse of sin x. Sin x I can write it as 2 sin x by 2 into cos x by 2. As we know, sin 2 theta is equal to 2 sin theta cos theta. So sin x is equal to 2 sin x by 2 cos x by 2 divided by 1 plus cos x. 1 plus cos x is equal to 2 cos square x. 1 plus cos theta equal to 2 cos square theta. So here 2 gets cancelled. Cos x by 2 cos x by 2 gets cancelled. We are left with tan inverse of sin x by 2 divided by cos x by 2. Sin x by 2 divided by cos x by 2 can be written as tan x by 2. Tan inverse of tan x by 2 is equal to x by 2. So y is equal to x by 2, y dash, now differentiate it. Derivative of x by 2 is 1 by 2. Let's go to the next question. If y is equal to tan inverse of cos x plus sin x divided by cos x minus sin x, y is equal to tan inverse of cos x plus sin x by cos x minus sin x, then prove that y dash is equal to 1. Then prove that y dash is equal to 1. Okay. So we have y is equal to tan inverse of cos x plus sin x divided by cos x minus sin x. Now here I will divide both the numerator and denominator by cos x. I am dividing by cos x. When I divide by cos x by cos x, first term will give you 1 plus second term sin x by cos x, that will become tan x divided by, here also cos x by cos x will give you 1, sin x by cos x is tan x, then 1 plus tan x by 1 minus tan x. 1 plus tan x divided by 1 minus tan x will give you tan pi by 4 plus x. It's a well known formula. 1 plus tan theta by 1 minus tan theta is equal to tan pi by 4 plus theta. If it is 1 minus tan theta by 1 plus tan theta, then it will become tan pi by 4 minus tan theta. So here it is on the form 1 plus tan theta by 1 minus tan theta, which is equal to tan pi by 4 plus theta. So here I am writing this expression as tan pi by 4 plus x. Okay. Tan inverse of tan pi by 4 plus x is equal to pi by 4 plus x. As we know, tan inverse of tan y equal to y. So tan inverse of tan pi by 4 plus x is equal to pi by 4 plus x. Now let us differentiate. Y dash is equal to pi by 4 is a constant, so its derivative is 0 and the derivative of x is 1. So that is what we want to prove. Okay. next. Let's go to the next set of problems. Differentiate the following functions with respect to x. Differentiate the following functions with respect to x. Differentiate the following functions with respect to x. First problem. Tan inverse of 2x by 1 minus x square. Tan inverse of 2x by 1 minus x square. Okay. So I will call this as y. Let y is equal to tan inverse of 2x divided by 1 minus x square. Okay. Now here I will make a substitution. 2x by 1 minus x square we have. I will make a substitution as put x equal to tan theta. Okay. So when I put x equal to tan theta, this expression will be tan inverse of 2 tan theta divided by 1 minus tan square theta. 2 tan theta divided by 1 minus tan square theta. Tan inverse of 2 tan theta by 1 minus tan square theta. 2 tan theta divided by 1 minus tan square theta is equal to, this is a well known formula, that's equal to tan 2 theta. So we have y is equal to tan inverse of tan 2 theta. Okay. Tan inverse of tan 2 theta. Tan inverse of tan 2 theta will give you 2 theta. Okay, tan inverse of tan 2 theta is 2 theta. What is theta? We have taken x is equal to tan theta. Therefore, theta is equal to tan inverse x. That will give you y is equal to 2 tan inverse x. Y equal to 2 tan inverse x. Now we differentiate this. Y dash is equal to 2 into derivative of tan inverse x is 1 by 1 plus x square. So answer is 2 divided by 1 plus x square. Okay, students, some of you might be able to directly write this as 2 tan inverse x. You may know this formula. Tan inverse of 2x by 1 minus x square. We can directly write it as 2 tan inverse x. That can also be done directly from here. You can reach this stage and then differentiate. Next question. Sine inverse of x by root 1 plus x square. Sine inverse of x divided by root of 1 plus x square. Sine inverse of x by root 1 plus x square. We will call this as y. Let y is equal to sine inverse of x divided by root of 1 plus x square. I will make a substitution here as put x equal to tan theta. Why do I take x equal to tan theta? Is because you observe here we have root of 1 plus x square. If I take x as tan theta, then we will get 1 plus tan square theta, which can be written as secant square theta, and simplification will be easy. So I am taking x as tan theta. That will imply that theta is equal to tan inverse x. Coming to this now, y is equal to sine inverse of x. In place of x, I am writing tan theta divided by root of 1 plus x square we have. In place of x, I am writing tan theta. So x square will become tan square theta. So y is equal to sine inverse of tan theta divided by square root of 1 plus tan square theta. I am writing 1 plus tan square theta as secant square theta. 1 plus tan square theta is a well known formula, that's equal to secant square theta. Then tan theta divided by secant root of secant square theta. I will write it as secant. Okay. Next, I will write the tan theta as sin theta divided by cos theta, and the secant theta can be written as 1 by cos theta. Numerator is sin theta by cos theta, denominator is 1 by cos theta, so that cos theta gets cancelled and we will be left with sin theta by 1, which is sin theta. So you have sin inverse of sin theta. Sin inverse of sin theta is nothing but theta. Sin inverse of sin theta is equal to theta. What is theta? We have made a substitution as x equal to tan theta, therefore theta is equal to tan inverse x. We have y is equal to tan inverse x. When we differentiate this, y dash is equal to derivative of tan inverse x is 1 by 1 plus x square. Let's look at the next question. Which function? Tan inverse of root of 1 plus x square minus 1. Tan inverse of root of 1 plus x square minus 1 divided by x. Tan inverse root 1 plus x square minus 1 by x. Okay. Here we have a root 1 plus x square. I will call this as y, and y equal to this. You write it in the next step. That y is equal to tan inverse of root 1 plus x square minus 1 by x. I will make a substitution as x equal to tan theta. Here also, because of the presence of this factor root 1 plus x square, I am going for x equal to tan theta. That will imply theta is equal to tan inverse x. Oh, so y is equal to tan inverse of root of 1 plus x square. We have in place of x I am having tan theta and substituting tan theta. So 1 plus tan square theta will be minus 1 divided by tan theta. Okay. 1 plus tan square theta is secant square theta. So you have root of secant square theta minus 1 divided by tan theta. Secant square theta, root of secant square theta will be equal to secant theta. So you have tan inverse of secant theta minus 1 divided by tan theta. Okay. That's equal to tan inverse of secant theta. I will write secant theta as 1 by cos theta minus 1 divided by, in the denominator we have tan theta, which I am writing it as sin theta by cos theta. Okay. Now take LCM. LCM is cos theta here. So in the numerator you will have 1 minus cos theta divided by cos theta, and in the denominator we have sin theta by cos theta. That cos theta gets cancelled, so we are left with 1 minus cos theta divided by sin theta. Okay. Further, y equal to tan inverse of this 1 minus cos theta, we can write that as 2 sin square theta by 2, and denominator sin theta is there. That sin theta, we can write that as 2 sin theta by 2 cos theta. Okay, then y is equal to tan inverse of, here 2 gets cancelled, sin theta by 2 gets cancelled. Here one of those sin theta by 2 gets cancelled, other sin theta by 2 will remain in the numerator, and in the denominator cos theta by 2 will remain. Sin theta by 2 divided by cos theta by 2 will give you tan theta by 2. Then tan inverse of tan theta by 2 is equal to theta by 2. What is theta? We have taken x equal to tan theta, therefore theta is equal to tan inverse x. Hence this y will be equal to 1 by 2 into tan inverse x. Now if you differentiate, y dash is equal to 1 by 2 into 1 by 1 plus x square. 1 by 2 is a constant, will remain as it is. Derivative of tan inverse x is 1 by 1 plus x square. Next question. Tan inverse of x plus a by 1 minus x. Tan inverse of x plus a divided by 1 minus ax. Okay. So now we'll call this as y. Let y is equal to tan inverse of x plus a divided by 1 minus ax. Okay. Here we don't have to go for any substitution. This is of the form tan inverse of x plus y divided by 1 minus xy. Tan inverse of x plus y divided by 1 minus xy. You know this formula, tan inverse of x plus y divided by 1 minus xy. This is equal to tan inverse x plus tan inverse y. This formula I would like to use. Tan inverse of x plus y by 1 minus xy is equal to tan inverse x plus tan inverse y. So by using that formula, we can write this as tan inverse x plus tan inverse a. Okay, now you can differentiate it. Derivative of tan inverse x is 1 by 1 plus x square. Derivative of tan inverse a, don't write that as 1 by 1 plus a square. That's not correct, because a is a constant and therefore tan inverse a is also a constant. Hence its derivative is 0. So for this, the answer is 1 by 1 plus x square. Next question. Cot inverse of of 3 minus 2 tan x divided by 2 plus 3 tan x. 3 minus 2 tan x divided by 2 plus 3 tan x. Question is said, differentiate this with respect to x. Okay. Cot inverse is there. I will write in terms of tan inverse. You can write this as tan inverse of 2 plus 3 tan x divided by 3 minus 2 tan x. Because we know cot inverse x is equal to tan inverse of 1 by x. Okay? Cot inverse x can be written as tan inverse of 1 by x. Make it simple. Okay. Now, I'll call this as y as always. I'll divide this numerator as well as denominator by 3. Dividing numerator and denominator by 3. So when I divide by 3, this will give you 2 by 3 plus. Here 3 gets cancelled, so you have tan x. Divided by here 3 gets cancelled, 1 minus this will become 2 by 3 into tan x. So tan inverse of 2 by 3 plus tan x divided by 1 minus 2 by 3 into tan x. Okay. Now this looks like tan inverse of x plus y divided by 1 minus xy. Just like what we did in the last problem, it is also of the form tan inverse of x plus y divided by 1 minus xy. Tan inverse of x plus y by 1 minus xy is equal to tan inverse x plus tan inverse y. So I can write this expression as tan inverse of x in place of x we have 2 by 3 plus tan inverse of y in place of y we have tan x. Okay, so y is equal to tan inverse 2 by 3 plus tan inverse of tan x which is equal to x. So we have tan inverse 2 by 3 plus x. Now differentiate this. Y dash is equal to 2 by 3 is a constant and therefore tan inverse 2 by 3 is also a constant. Hence its derivative is 0 plus the derivative of x which is 1. So the derivative of this expression is 1. Okay. Now some of you may get a doubt. Sir, when you explain that we understand, but how do we realize that we should divide by 3 only? Why not any other number? There are so many other real numbers also, but you choose 3 only. It is because, look at this expression. See, whenever we get an expression of this kind, either we want to use sinus of x plus y by 1 minus xy, or we want to use sinus of x minus y divided by 1 plus xy. That is, this plus here minus here, or minus here plus here. In either the case, this should be one only, whether it is x plus y by 1 minus xy or x minus y by 1 plus xy. We have to make this term as 1. How can I make this term as 1? I can make this term as 1 if I divide by 3. Okay? So when I divide by 3, this is what we have got, sinus of x plus y divided by 1 minus xy. So keep in mind that we have to make this as 1. Then now, before I go to the next set of problems, I would like to give you few problems as homework. Just write down. Question is saying differentiate the following functions with respect to x. Just note down these questions. Sine inverse of 2x divided by 1 plus x square. Cos inverse of 1 minus x square by 1 plus x square. Tan inverse of 3x minus x cube divided by 1 minus 3x square. Tan inverse of 1 minus x by 1 plus x. Tan inverse of a minus x by a plus x. Okay. After that, another question is if y is equal to tan inverse of root 1 minus cos 2x divided by 1 plus cos 2x, then prove that y dash is equal to 1. Y dash equal to 1. Then if y is equal to tan inverse of cos x by 1 plus sin x, then prove that y dash is equal to minus 1. Okay. Solve these problems. If you have any difficulties, you can ask in our WhatsApp group. Let us look at some more problems. The next question is differentiate this with respect to x. Function is tan inverse of root x into 3 minus x divided by 1 minus 3x. Tan inverse of root x into 3 minus x divided by 1 minus 3x. Okay, as always I will call this as y. That's equal to tan inverse of, I'll take this root x inside. This will come through 3 root x minus x into root x divided by 1 minus 3x. Okay? This root x I have taken inside. So 3 root x minus x root x. Now I will make a substitution as put root x equal to tan. Put root x equal to tan theta. This will imply that theta is equal to tan inverse of root x. Okay. Now let us see what happens. Y is equal to tan inverse of 3 root x. I am substituting root x as tan theta, so this will become 3 tan theta minus x into root x. Root x is tan theta. Then what is x? Root x is tan theta, so x is equal to tan square. This will become tan square theta, this will be tan theta, tan square theta into tan theta, it will become tan cube. Okay? tan square theta into tan theta, that is tan cube theta, divided by 1 minus 3 into x. Root x is tan theta, so x is tan square theta. So you get 1 minus 3 tan square theta. Okay. So you have 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. This is a very well known formula. 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta is tan 3 theta. So y is equal to tan inverse of tan 3 theta. Okay? 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta is equal to tan 3 theta. So y is equal to tan inverse of tan 3 theta is 3 theta. Tan inverse of tan 3 theta is equal to 3 theta. What is theta? Tan inverse of root x. So you have 3 tan inverse root x. Now let us differentiate this. Y dash is equal to 3 is a constant, will remain as this. Derivative of tan inverse root x. Derivative of tan inverse x is 1 by 1 plus x square. So derivative of tan inverse root x is 1 by 1 plus x square. In place of x you have root x whole square into the derivative of root x. Derivative of root x is 1 by 2 root x. So y dash is equal to 3 by 2 root x into 1 plus x. Root x whole square is this. Next question. If y is equal to sine square cot inverse of, if y equal to sine square cot inverse of root of 1 plus x by 1 minus x. Cot in sine square cot inverse of root 1 plus x by 1 minus x. Then prove that y dash is equal to minus 1. Prove that y dash is equal to minus 1 by 2. Okay. So we have y equal to sine square cot inverse of root of 1 plus x by 1 minus x. So now here I will make a substitution. Observe, here we have root 1 plus x as well as root 1 minus x. Earlier I told you, when you come across root a plus x or root a minus x, put x equal to, the substitution is put x equal to a cos theta. Now in this case a is 1, so put x equal to cos theta. I will make a substitution as x equal to cos theta. When I take x equal to cos theta, immediately I can write that theta is equal to cos inverse x. So now you substitute. Y is equal to sine square cot inverse of root of 1 plus x. In place of x I am writing cos theta. Denominator will become 1 minus cos theta. That's equal to sine square cot inverse of root of 1 plus cos theta. We have a very well known formula for this. 1 plus cos theta is equal to 2 cos square theta. 1 minus cos theta, that is 2 sine square theta. Oh, 2 gets cancelled. Cos square theta by 2 divided by sine square theta by 2. That will become cot square theta. Sine square cot inverse of, see here 2 gets cancelled. Cos square theta by 2 divided by sine square theta by 2, which will give you cot square theta by 2. Square root of cot square theta by 2 is cot theta by 2. Okay? So now sine square cot inverse of cot theta by 2. Cot inverse of cot theta by 2 is equal to theta by 2. Okay? So this expression we have reduced it to sine square theta by 2. We have taken theta, we have taken x as cos theta. So theta will be cos inverse x. Now there if I substitute, I am going to get the sine square 1 by 2 cos inverse x. Differentiating that also will take a bit more time. So instead of that, what I do is, I I would like to express this sine square theta by 2 in terms of x, that is in terms of cos theta. So what do? I'll write sine square theta by 2 as 1 minus cos theta divided by 2. Okay, from where do I get it? Say 1 minus cos theta. What is 1 minus cos theta? 2 sine square theta by 2, a very well known formula. So if I cancel that 2, we will end up getting sine square theta by 2. See, this is a very well known formula. 1 minus cos theta is equal to 2 sine square theta by 2. Now what did I do? I brought this 2 to LHS. So we get 1 minus cos theta divided by 2 is equal to sine square theta by 2. So I am replacing 1 sine square theta by 2 with the 1 minus cos theta by 2. So what is the intention behind using this formula? The intention is that here we have the expression cos theta. We have taken x is equal to cos theta. So I shall replace that cos theta with x. Okay. So we have y is equal to 1 minus, in place of cos theta I am writing x divided by 2. So if I split it, 1 by 2 minus x by 2. Now if I differentiate it, see, now you might, why did we make all these substitutions? Because say differentiating this is a much more difficult task than differentiating this. That is the reason why we have made this substitution and did all this simplification. Okay. Now if you differentiate it, y dash is equal to derivative of 1 by 2 is 0 minus derivative of x by 2, which is 1 by 2. So the answer is y dash is equal to minus 1 by 2. That's exactly what we want. Okay. Students, with this I will stop today's class. We shall continue in the next class. Thank you.